Wikipedia describes C# as, quote, a multi-paradigm programming language encompassing strong typing, imperative, declarative, functional, generic, object-oriented, class-based, and component-oriented programming disciplines. Okay, that's a rather amazing and accurate buzzword-laden description of the language's primary characteristics, giving a hint as to how it's designed to support both a variety of application types as well as programming styles and methodologies. ECMA lists several design goals for C# in the standardized language specification. C# is intended to be simple, modern, general-purpose, object-oriented programming language. The language and implementations thereof should provide support for software engineering principles such as strong type checking, array bounds checking, detection of attempts to use uninitialized variables, and automatic garbage collection. Software robustness, durability, and programmer productivity are important. The language is intended for use in developing software components suitable for deployment in distributed environments. Source code portability is very important, as is programmer portability, especially for those programmers already familiar with C and C++. Support for internationalization is very important. So that means that you can write C# applications that are usable by people all around the world supporting their specific languages and cultures. C# is intended to be suitable for writing applications for both hosted and embedded systems, ranging from the very large that use sophisticated operating systems down to the very small having dedicated functions. And then finally, although C# applications are intended to be economical with regard to memory and processing power requirements, the language was not intended to compete directly on performance and size with C or assembly language. So C# does have its limitations. These are ambitious design goals, which C#, since it's mature and a widely used language, it largely fulfills those goals. For the most part, it's largely supplanted Visual Basic as the primary programming language of .NET applications, and has relegated Visual Basic to a minor role at best. And I say that with a bit of sorrow, because I'm a Visual Basic programmer from way back, predating the .NET framework and coming from other languages before Visual Basic, but I just do C# in my day job all day long now. C# really is the main programming language of the .NET framework. Anders Heilberg is C#'s principal designer and lead architect. At the point when he created C#, he had already had a long and successful career of creating programming languages, notably including Borland's Turbo Pascal and Delphi, which were dominant programming languages in their day. He left Borland to join Microsoft as a Microsoft Distinguished Engineer and remains there to this day. During the early days of .NET framework development in the late 1990s, Heilberg formed a team to build a new language for the new programming paradigms presented by .NET. The language's original name was COOL, an acronym for C-like Object-Oriented Language. By the time .NET's initial release in 2000, Microsoft had renamed the language to C#, the name it bears today. Over time, C# has grown in features and power, both to support new application types and operating system features, as well as to add features to simplify and streamline code. C# has its roots in C++, as well as, arguably, Java, both of which are object-oriented descendants of C. All three languages are in wide use today, but have followed very different trajectories as software developers have figured out what each are best for, and the languages have followed their lead in terms of new features that they get. The name C# came from a musical notation. A sharp is a semitone, higher in pitch than the bass note, so C# has a higher pitch than C. This continues a whimsical tradition of naming C-derived languages. For example, C++ got its name from the ++ increment operator in the language, implying that C++ is one better than C. The convention is to use the number sign on a standard keyboard to type the name, but graphical representations of the name typically use the more stylized musical sharp symbol. In this course, I'm going to use the conventional number sign, just C#. Newer .NET languages have also used the same notation, notably F# and J#. When Microsoft finds a pattern it likes, it sticks with it. Here's the Wikipedia article about C#. And there you can see that stylized sharp, the musical symbol there. And that's the pound sign from the keyboard. So a couple different styles there. All right, so there's some really good information in this article, but I want to show you this versions. They have a real nice summary of the versions that have been released over time. And so it consists of different versions. C# 1.0. We're currently at C# 6.0. And by the way, Microsoft is internally conflicted about the right style. Typically, they say that C# 6 is the right way to write it, but even in some of their own documentation, 6.0 often appears. So you'll see it both ways. Don't worry about it. There generally is not minor versions. At least there hasn't been for way more than 10 years. Okay, and so each of these versions correspond to different specifications. So Microsoft started the language, and then ECMA, the European Computer Manufacturers Association, although they really don't go by that full name anymore, it's just ECMA, is the standardizing body. And then ISO has come out with a corresponding standard in most cases. And so you can see the number of versions, what corresponding versions they are for the different specifications that the three different organizations have come out with, as well as the date in which it was released. So you can see that the standardized version came out in 2002, so it was something like a couple of years after the .NET framework was introduced, because that came out around the year 2000. And as you can see, every, probably year or two or so, there's 3 years, couple of years, 3 years, so every 2 to 3 years, a new version of the standard is released. And it largely corresponds, or Microsoft really drives that, with the release of different .NET framework versions. Because with each version of the .NET framework, they introduce new features, and very often they'll add new language features to support new features within the framework. Okay, and there you can see the corresponding version of Visual Studio. So right now we're at C# 6.0. New updated standards have not yet come out, but they're working on them. And it was officially released, the standard was officially released in July of 2015, and it corresponds to the .NET Framework 4.6 and Visual Studio 2015. All right, so that's a summary of the versions. And then the second table has a summary of the features that came out in each. So C# 2.0, these are the features that were added. Added support for generics and partial types and anonymous methods and so forth. You can see all the features that were added with C# 3.0, 4.0, 5.0, and finally 6.0. So there's an awful lot of features added, mostly because of the adoption of the Roslyn compiler. Completely new way of compiling code. Not something that we're going to get into in any level of detail in this course whatsoever. Definitely an advanced topic, but you can actually guide how the language compilers do their work against code. It's really cool technology. Okay, and then you can see all of the other features that were added. And there's a little block down here that C# 7, looking into the future, are proposing declaration expressions and parameter arrays for IEnumerable interfaces. Okay, so at this point in your C# programming career, unless you've done some .NET programming, most of these things aren't going to make a lot of sense. You're not going to know what they are. By the end of all these C# courses, you should have a pretty good handle on most of this stuff. So don't worry about it for now. But all of this can be very handy if you get more advanced with C# and you're working with older applications. You need to see when or which version of C# added a particular feature, and you can come back to this because maybe you're working with code that was written with C# 4.0 and compiled with an older version of the framework. So just keep it in the back of your mind that this kind of information is available. C# provides a great deal of power and control when building applications. At a high enough level of abstraction that you don't have to spend a lot of time on the little details of interacting with the environment and resources. That way, you can spend your creative energy on the unique, interesting details of each application instead of getting bogged down in minutiae about reading from and writing to a disk file, implementing robust security over and over and over again in your applications, managing memory, and so forth. You have a great deal of control over all this, but you can exercise it in C# only if you really need to. Much of the power of C# comes from the language features, but a lot also comes from the CLR and the .NET Framework library. Since C# is tightly integrated with these, on whatever platform it's running, you have the full benefit of the associated resources. That means that you benefit from things like memory management, security sandboxing, runtime type checking, exception management, all through the runtime. And you have access to thousands of well-written, mature, proven objects that perform almost every kind of operation you can think of to share across multiple applications. And the framework is inherently extensible, so you can replace functionality that doesn't quite work for you or expand it to suit your unique needs. C# is a Microsoft creation. But in August 2000, which was not long after its initial release, the company submitted it to ECMA International. And as I mentioned, they were formerly known as the European Computer Manufacturers Association, ECMA, but have since changed their name to ECMA International. So they submitted it for standardization. Hewlett-Packard and Intel co-sponsored the submission. As a result, in December 2001, ECMA released ECMA 334, the C# language specification, which also later became an ISO standard called Information Technology C# Language Specification. The ISO standard mirrored ECMA's second version of the standard from 2002, and the two have stayed more or less in sync since then, and as the language evolves. The C# language, Common Language Runtime, and .NET Framework are the three primary components of a system that supports the creation of applications on Windows and are Microsoft products. Other implementations of the language for other platforms need to include equivalent components designed for those platforms, such as the Mac OS and Linux. The ECMA standard is designed to be platform agnostic. As a result, in addition to the C# specification, ECMA also defines ECMA 335, called the Common Language Infrastructure Specification, or CLI. Microsoft CLR and ECMA CLI both provide a runtime environment for C# code to execute in. But it would not be quite correct to call the CLR Microsoft's implementation of the CLI, because the CLI is a bit more encompassing than the CLR. Besides defining a virtual execution system, or VES, that is equivalent to the CLR, the CLI also defines the file format for library and executable files, a common type system, or CTS, and a subset of the CTS that languages need to implement to guarantee interoperability, which is the Common Language Specification. Okay, so it's easy to get bogged down in the details of Microsoft's implementation versus ECMA's specification. So just think of Microsoft's C#, CLR, and .NET Framework as the Windows implementation of ECMA's C# and CLI specifications. They just break it up in different ways, so just be aware of that difference. Now, vendors are welcome to expand beyond the specification for their platform, and Microsoft has most certainly done that with the .NET Framework. But you'll see references to this alphabet soup of specifications and implementations even in Microsoft's online documentation. So you need to have at least a nodding familiarity with what all the pieces are just to make sense of the information in that documentation.